In this video, we'll be doing the question you see on the screen from the 2023 Leaving Cert Higher Level Maths Paper 1. If you're looking for a different question from this paper, there should be a playlist in the description below. And if you're looking for a different paper entirely, have a look on my channel. I'll be doing all of this on a whiteboard, hopefully just like you're used to your teacher doing. But remember, we are on YouTube, so take advantage of that. Pause, try the question first, and even change the speed of the video to half speed or 2x speed if that's your thing. If you find this video or any of my videos useful, I would greatly appreciate a like, a subscribe, or especially sharing it with someone else you think might help. It might help. The setup for question 10 is all about a triangle of base 2, height 8. But we're setting up this sort of series where T1 is equal to the area of a rectangle drawn around this triangle. T2 is 2 rectangles, they're both equal height. T3 is 3 rectangles. And for part A, they simply want you to draw T4. Now they've given you a grid, quite helpfully the grid has 8 units high, which is the height of the triangle. So I won't do it. I won't do a big answer because what's the point? I don't have a ruler and stuff. But you have a triangle. Just count up or work out what is 1/4 of the height. So this is 1/3 of the height. Each of these. This is half the height. If this is 8, this is 4 and 4. This is 8 over 3, 8 over 3. 8 over 3. This one is 8 over 4 each time. 8 over 4 is just is 2. So just on your drawing, go up 2 units, and that's your first one. Starting at the point of intersection here, go up 2, and that's your second. Go up 2, that's your third. Go up 2, which should be right at the top. That's your fourth. That's all they want you to do for part A. Now part B is, there's a really short, easy answer to part B that I found after a while. I did it the long way first, but I will show you it at the end. But I think most students are going to do this the long, difficult way. And I think a lot will probably have difficulty with it. So I'll do my best to do it slowly, show you what I'm thinking, how I would have figured it out myself. But part B, they want you to work out the total area of T3. It's part C that's more difficult maybe. Well, they're both a bit difficult and they both sort of work together. So it's part C, there's a shorter, quicker way to do. The total area of this. No, sorry, not this. This is T4 here, isn't it? T3, they want you to work out the total area of T3. So the main way to do this is just break it into 3 rectangles. That's what I'm going to do, although I'm going to be a little careful when I do that, because I know what's coming next. In the next one, they want us to find a pattern for all of them. So I'm going to do this, I'm going to do the bottom rectangle first, and I'm going to try and keep it quite neat as best I can. So let's break this up into 3 parts. The height of this bottom right rectangle, let's do it this way. We're going to add this plus a smaller one, same height, but smaller, plus the last one, same height, but smaller again. That's these 3 rectangles. The first rectangle, the height of it is 8 over 3. 8 over 3, and the width is 2. The second one, height we know, 8 over 3. Last one, 8 over 3. But what's the width? That's going to be a side quest. We'll do it over here. We need to find the width of each of these. And once we figure it out for one of them, we'll hopefully see a pattern for all of them. Well, let me continue on here actually first. This is just 8 over 3 multiplied by 2. This one is just 8 over 3 multiplied by something, and this one is 8 over 3 multiplied by something. This is going to help me for my pattern later. So what is this something? What's the width? The width of this 2. What's the width of the next one? Well, let's zoom in over here, and we'll look at the base 2. Triangle goes up somewhere like this. Just these bottom 2 I'm looking at. We know this is 8 over 3. We know this is 8 over 3. What's this height here? And the secret is, there's no Pythagoras unfortunately here. The secret here is, and it's maybe difficult to notice, but it's to notice that this triangle this triangle, let me draw it in the last one. This triangle, all of these are similar. This angle equals this angle equals this angle. This one up here equals this one equals this one. Okay, so they're all similar. We figure one out, we figured them all out. But the real trick is to notice, if I split this in half, this triangle is similar. So the top, this angle in here is the same as this one. This angle down here is the same as this one. So, and this triangle is similar to the whole one. This angle down here is the same as this one and this one. This little triangle up here is obviously the same as itself. So we have similar triangles. So all these triangles are all the same. 8, half this base is 1. All of these triangles, every one of these ones on the side is similar to this 8-1 triangle. So if you know this is 8 over 3, I know this length here is 1/8 of that. If this is 8, this is 1/8 of it. If this is 8 over 3, this is 1/8 of that. So that's 1 over 3. 1 over 3. All of these are 1 over 3. 1 over 3. So what does that make this length? If this is 2, we're taking away 1 over 3 and another 1 over 3. This is 2 minus 1 over 3 minus 1 over 3, which is equal to, let's see, 4 over 3. So this length here is 4 over 3. And this one again up top here is this length minus 1 over 3 minus another 1 over 3. So it's 4 over 3 minus 1 over 3 minus 1 over 3, which is 2 over 3. This is 2 over 3. This is 4 over 3 in here. It's 2 over 3 in here. Hopefully you followed along. It's definitely not something that's easy to teach this. It's a puzzle that you sort of have to solve yourself. Hopefully, like, pause it, rewind, watch this again. Try and figure out this puzzle. The important parts are a similar triangle to all of these. All of these are all similar triangles to half of the main thing. And that main triangle is 8 over 1. All of these are similar to that. That's where I'm working out these lengths. And I'm just taking 2 of them away. So I get this. I could write this again like this actually. 8 over 3 multiplied by 2 plus 8 over 3 multiplied by 2 minus 2 1 over 3s plus 8 over 3 2 minus 4 1 over 3s. That's probably the pattern I'm seeing here. To answer part B, we just put all this into a calculator and we get, I'm not even sure what we get. Oh, they give us the answer, don't they? Yeah, put all this in a calculator, we get 32 over 3. And now you might think I spent a little long doing that. That's partially because part C, which I'm moving on to now, wants you to find the pattern in all of this, so we can do T4, T5, T6, Tn, any one we want. So I wanted to try and get the pattern out of there. I'm going to rub out over here. I'll leave a lot of this on the board. I'll rub out over here, and we'll do this again for T4, and we'll see if we see a pattern. Actually, we'll do it for T2 and then T4. We'll see if we can find a pattern to copy. But as I said earlier, there's actually a quite easy way to do this, but it's easy in how short it is, but it's a really clever way. So I want to wait to after doing the longer, messier way first. Okay, I'm going to rub this out and we'll continue. So this was T3. This was 3 of the blocks. Let's find T2. We squeeze it up into this gap up here. T2 is the bottom block, which is half of, this was 8 over 3. This is 8 over 2, or 4. So this would be 8 over 2. And it's multiplied by the length, which again is 2. Very similar, 8 over 3 times 2. 8 over 2 times 2. Plus this one on top. So basically, what is this height here? This height is 4. What is this width here? I apologize. So again, we have to follow this similar pattern. 8 to 1. This is 1 and 1. 8 to 1. 4 to a half. This must be a half. Must be another half. So it's 8 over 2 multiplied by 2 minus 2 halves. And that's it. So that's the area for T2. I don't need to multiply it out. This is the area for T3. T4, and I'll do it a little slow, but hopefully we see the pattern already. T4 is the height of this guy, which is 8 divided by 2. 8 divided by 4, which is 2. But I'll write it as 8 divided by 4. The width, just 2. Same. The next one is again 8 over 4 multiplied by 2 minus, and what's this width here? Hopefully you can see this, but this is this height is 2, so this must be a quarter. To keep the ratio 8 to 1. 8 to 1 ratio is the important thing here. So we have 2 take away 2 quarters. Because remember, there's a quarter here and a quarter here. All of these steps are quarters then. I'm going to run out of room here, but it's 8 over 4 times 2 take away another. So take away this 2 and this 2. So it's minus 4 1 over 4s. And we have another one down here, 8 over 4 2 minus 6 1 over 4s. So that's the pattern I'm seeing here. So we could just write Tn out. It's a bit messy. We can clean this up. I'll clean it up. I'll clean it up everywhere here. This could be 8 over 3 is fine. 2 could be 8 over 4. 6 over 3. I want everything to be a 3. I'm sorry. This guy could be 4 over 3. Is already. Oh yeah, this is already done. Sorry. So 6 over 3, 4 over 3, 2 over 3. This could be made into this number here, 8 over 4. This number would be 8 over 4 take away 2 over 4s. That's 6 over 4. 8 over 4 minus 4 over 4s. That's 4 over 4. This last one here would be 2 over 4. See the pattern? It's going down 2 each time. Let me rub out up here, and we'll put in Tn. If you see the pattern, hopefully. Okay, I rubbed out a few things I didn't mean to. This is T3 here. I've just added in some extra numbers. T3. This is T4. Let's try and make a guess what Tn would be. Tn. It seems to me that the pattern is 8 divided by n. 8 divided by 3. 8 divided by 4. That's an important number. So 8 divided by n. And it goes into every one actually. It goes into every term. So let's just open a big bracket to that. Okay, what's next then is, it seems to be always 2. Always 2 is the first term. I'm just to make it look a bit more reasonable, I'm going to write 2 as 2n over n. Don't worry if you don't have that. It's just makes it look a little better. It's okay if you add that in a little later though. The next term just seems to be 2 less than that, on the top row at least. So the next term just seems to be 2n take away 2. 6 over 3, 4 over 3, 2 over 3. That's why I added in this 2n, otherwise it might look a bit messy. And this just continues on forever until the last 2 terms. And the last 2 terms are always, well, the last term is always 2 over 3, 2 over 4, 2 over n. The second last term will be 4 over n. So it just goes up. In fact, it's often better to write this the other way. It's going up this way instead of it's going down. But honestly, both work. And this is the answer. This is the area for Tn. Except they wanted it in the simplest form. This isn't that simple. So we're left with another step here. Actually, first we can take lots of things out of this. We can take n out of every single term. So let's just put a line through all of them and we get n squares out here. We can also take 2 out of everything. Some people will do that, some won't. It will change your answer. Yeah, let me talk about that in a moment. And the next thing I want to notice here is this is an arithmetic sequence. It just starts with 2 and it goes up 2 every time. Or it starts with 2n and it goes down 2 every time. Arithmetic sequence is something we understand very well. We have formulas for it. To add them all up, I'll write it up here. Sn is equal, I better look it up, n over 2, do I have it somewhere? Yeah, n over 2, 2a plus n minus 1 times d. We can add up an arithmetic term. All we need to know is what the first term is, and there's lots of choices here. Like I said, you could say 2n is the first term, and the difference d is minus 2. It goes down 2 every time. Or you could say 2 is the first term. That's what I'll do here. A is equal to 2, and it goes up 2 every time. D is equal to 2, and I guess n is equal to n just. Again, you could take 2 out of everyone, and you'd have a is equal to 1, and d is equal to 1. That also works. That's actually very neat because it's a very famous thing, 1 plus 2 plus 3 plus 4. It's a very famous series. But let's just stay on with this one. We just put everything into this formula. We get, don't be confused by Tn. T is for triangle, not the series this time. So Sn or Tn, well, sorry, no, Sn is different. Actually, Sn is equal to 8 over n squared Tn is equal to this times Sn. So we need to work out what Sn is by filling in this formula. That's n over 2 times 2 times a is 4 plus n minus 1 times d, which is 2. Again, if you had taken this is 1, you would have taken a 2 out, so there'd be 16 out here, so it'd work out the same. We clean this up as best we can. We get 2n minus 2 in here. 4 minus 2 becomes a 2. Let's start multiplying things out. We get, this n cancels one of them. 2 cancels into this, we get 4. So we're left with 4 multiplied into 2 plus 2n. We're left with 8 plus 8n. Sorry, I went a bit fast there. I realise this has gone very long already. And that's the final answer. You would have got that if you used a is equal to n, d is equal minus 2. You would have got that a few different ways. That's very long and complicated way, but I think that was most students' best chance to doing this. I'm going to clean off this left side and do the question again in maybe 2-3 minutes. It's a much easier way to do it, but it's a much more difficult way to see. Okay, to redo part C, what we have here is a triangle with n. They want to get n steps onto this. So I'm just going to draw small ones here. Obviously I can't draw n because it could be any number, it could be infinity, it could be 5, it could be whatever. But there's lots of really small steps here. It goes all the way up. I won't put them all in obviously. And it goes all the way to the top. There's n of these steps. And the total area of all of these rectangles is, and it's a little trick to notice, is actually equal to the area of the triangle, which is, 8 times 2 times a half. So the total area is 8 of this triangle plus all of these little triangles. All of these little triangles on the end. And there's we can count how many there is. There's n steps. There's 2 every step. So it's like 2n of these guys. So if we can just work out the area of this little triangle, we'll zoom into one of them here. Let's see. Yeah, we'll zoom in. This goes off up to the big triangle. If we can find the area of one of these, we're pretty much done, and we can find it. The total height is 8, and there's n of them. So this height is just 8 over n. And as I said many times earlier, the triangles are all similar to the main triangle. So if this height is 8, this height is 1. If this height is 8 over n, this height is, 8 over n divided by 8, which is 1 over n. So this triangle, the area of this triangle, 8 plus 2n, the area of this triangle here is just a half times, we call this the base, half the base times the perpendicular height, 8 over n. And we just put all this in. We get one of these n's cancel with this n, and the 2 cancels with the 8, we're left with 4. So we're left with this 8, 2 times 4 is 8, and it's just an n on the bottom, which is the answer. It took us 10 minutes of lots of messy writing to get. That's the full answer there. But honestly, in the exam I would have done it the long messy way. I only noticed this trick later. Okay, in part D they change it up. We have the same triangle, but they say it's a different sequence of rectangles. They don't tell us what it looks like at all. They do tell us their area is equal to 8 times n minus 1 over n. So they tell us the answer really that we had to work out earlier. They want us to work out what value of n would mean that all the rectangles added up, the an, is greater than 95% of the area of the main triangle, which I guess I'll keep that over here. That's 8 times 2. So the area of this is 8. So they want to know is when is this 8n minus 1 over n greater than 95% of this, which is, I think I worked it out to 7.6. I guess I should double check that. Yeah, 7.6. So really, they just want us to solve this equation here. You could solve it, just put an equals in and work out the number later. It's a little dangerous. I'll leave it in like this. Just be careful not to multiply by minuses, things like that. So we multiply both sides by n. N is a positive number, so we're set there. That's 8n minus 8, I'm just multiplying this in, is greater than 7.6n. We take this away from both sides, that doesn't change any signs. So 8n minus 7.6n is 0.4 n's. We add 8 to both sides, again doesn't change any sign. We left with that. Divide both sides by 0.4, it's a positive number, so we're fine again. And where n is greater than, is it 20? 20. So just be very careful, n is not equal to 20. It's not greater than and equal. But they said explicitly greater than, not greater than or equal. So the answer, let's work out the first value, n must equal 21. That's it. Be careful if you had used an equals here and got equals 20, you would have been tempted just to say 21 and you would have been right. But if you had have ended up multiplying by a minus somewhere, it might have been 19 could have been the answer. So probably best, if you did get n equals 20 and just guess 21, it would have been better probably to test 21 and 19. For example, in the previous part, the rectangles were bigger than the triangle. So it was always bigger than 95%. So in this question, it must be, I'd say it's probably rectangles inside the triangle or something like that. Either way, the answer is 21. The last part of this already very difficult question, question 10, part E, isn't as hard as it looks. They've set up 2 pyramids, square-based pyramids. Lots of English telling us about it. But they tell us the volume of they tell us the area of this cut here. Let me write that down. The area is S of x, and it equals x squared c squared over h squared. So that's very helpful. They tell us this cut here. We could work that out ourselves. And then they tell us the volume of the main thing is equal to the integral between 0 and h of sx dx. Okay. And they want us to use integration to find the volume. If you didn't understand any of that, this question is still quite easy. All they want you to do is integrate sx, and there's sx. Put it in, integrate. It's quite a short, easy question. I just want to explain a little more. They've told you everything about this little slice. And what integration does is it adds up lots of things. So when x is the height between here and here, and when x is 0, this is x 0 by the way, that's over dx between 0 and h. When x is 0, that slice is 0. So they add that, plus a tiny slice, plus another slice, plus another one. And when you add all them together, you build a pyramid. And remember, it's not 100 slices, not 1,000, it's not 1,000,000, it's infinite slices. So we get a perfectly smooth thing. This is just like when we get the area underneath a curve. We add up all the heights and we get an area. Here we're adding up all the areas and we're getting a volume. That's one of the powers of integration. But like I said, it's not that bad when we just write out the question. It's the integral between 0 and h of x squared c squared over h squared with respect to dx. But c and h are constants, so they don't have to stay in there. C squared, h squared can come out. So all that's in here is x squared dx. This is an integration everyone in honours should be able to do. If we write that again up here, we'll take c squared and h squared, keep it out. Integral of x squared is just x cubed divided by 3. It's 1 over 3. We just need to evaluate this between 0 and h. So we put h in, and we would get c squared, h cubed, that's the h going in, divided by 3. And then we put 0 in, but 0 for the x would be 0 multiplied by pings, which is just 0. So the 0 doesn't even need to go in. And we just need to cancel these 2 h's here, 3 h's here. We're left with 1 h. So the full answer is c squared h times h over 3. That's the full answer for part 1. For part 2, I hope I don't run out of room. I think I can squeeze it in here. I always think I can do these things. We have to read English here and turn it into maths. It's a rate of change question. That's very common, but so we have to do it. So they say, I'm going to read it carefully. They say x starts to increase at a rate of 3. So what that really means is x is changing with respect to time at a rate of 3. That's how we write that. X is changing with respect to time at 3 units. So that's what they've told us there with that line. The next line is, they tell us that causes Sx to change. Fine. They tell us what we're looking for. We're trying to find the rate of change of Sx. And when they say rate of change, they say with respect to time. So what we're looking for is ds dt. That's what we're looking for. At a specific point, at an instant when x is half the height. So that just says when x equals h over 2. So that's what we're looking for here. So that's what all that English turned into. And this is a very common, we just always use the chain rule. We're looking for this answer. We're looking for ds dt. And the chain rule tells us that's the same as ds, anything we want, dx. Once the same things are here, dt. And the great thing, we know this one, dx dt. ds dx isn't too hard to get. We know everything about s. So we can just do this part on its own. ds dx is just the integral, the derivative of this, and these are constants. So it's just 2x multiplied by the constants. So it's 2 from this 2. The c squared is still there, the h squared is still there, and it's an x. That's all. So really we just need to put in, we need to put this into this. I guess I'm going to run out of room. Let me rub out a bit on the left side. Okay, so remember we're still looking for ds dt, but we now know a lot. Ds dt at x equals h over 2 is equal, and we know that from here, is equal ds dx, which we now know is 2c squared over h squared times x. But remember, x is equal to h over 2. We put that in. That was here, that was in there, and then we just need dx dt, which is just simply 3. That's our answer. They never told us to get any numbers. We can assume they wanted in terms of c and h. C and h, that's perfect. It's not very neat. We can clean this up a bit. For example, a h here will cancel one of their h's. This 2 will cancel with that 2. And that's as good as I can get. 3c squared over h. That's a full marks for part 2. Okay, that was a really hard question. There was a lot of clever steps to take. And And even then, there was, if you didn't take a really clever step on part C, there was a lot of work to do in it. I hope I was able to teach it somewhat well, but I'm sure you're going to have some follow-up questions if you got this far in the video. So feel free to put them in the comments. I'll do my best to answer you. Thanks for watching and have a great day.